So let us talk about the domain of a radical function and a rational function. So I have the first question here, that is a radical function. So a radical function is a function that is in the square root. And one thing I want you guys to understand is that whenever we're talking about radical function, we should understand that we can never have the square root of a negative number. So if you have got the square root of a negative number, that is undefined. Okay? So if it is undefined, to make things defined, the only thing that we can have in the square root is starting from 0 going to positive infinity. Okay? I can have the square root of 0 is 0. 1, 1. So as long as I've got 0 going to positive infinity, that is okay in the square root. So what conclusion can I make? I can say that everything that I'm going to have in the square root, I equate them greater than or equal to 0. Then I solve for x. That's the domain. So for any domain, for any kind of a radical function, and we are trying to find the domain. So you just get what is in the square root, x minus 3 greater than or equal to 0. Why are we equating to greater than or equal to 0? Because we know that the only thing we can have in the square root is c starting from 0 going to positive infinity. At this point I can solve for x. X will be greater than or equal to 3. Meaning that the domain, since we are saying that greater than or equal to, we are including that number. So 3, starting from 3 included all the way to positive infinity. That's my domain. I can also put my answer in set builder notation, where I can say the domain x is such that, or you can say x is such that x is greater than or equal to 3, comma, x is a member of all real numbers. Other people will tell you to say set builder notation can be represented as x is a member of all real numbers such that x is greater than what? Is greater than or equal to negative 3. Oh, is positive 3, sorry. Positive 3. Okay? So you can also say that is the way it is. So one thing I want you guys to understand is that whenever we're talking about the radical function, we can never have a square root, we can never have a negative in the square root. If we have such case, then that is undefined, unless if I go back to now complex numbers, where I'm going to say I can find the imaginary number. Okay, now let us go to part 2. You can clearly see that part 2 is basically the same as the question we're from solving. I'll just get what is in the square root. Okay, I'll get what is in the square root. What do we have in the square root? In the square root we have 3 minus x greater than or equal to 0. Solve for x. This is the same as if I shift 3 to the other side, I'll have negative x greater than or equal to negative 3. But I can't have negative here. I need to divide both sides by negative 1. Even here negative 1. The moment you divide it by negative, this changes. If it is greater than or equal to, it will be less than or equal to 3. What does it tell us? The domain is starting from negative infinity all the way to 3, but 3 is included. Or you can say domain x is such that x is less than or equal to 3, but x should be a member of all real numbers. So that's how we write the domain. Okay, so we are interested in the number of the values of x that can fit, that can make the function defined. Okay, now I'll first go to part T. I'll jump. I'm not going to do this one first. I'll first solve this one, then I'll come back to that one. Okay, so now I want you to understand that whenever we're talking about it, there's what we call the square root, the fifth root, and the fourth root. So these two guys are basically the same. What happens here is the same as what happens there is basically the same as what's going to happen where? What's going to happen where there's 4 there? Okay, that's what we need to know. But now I want to show you something. So in that case, I'm going to say 1 minus x is greater than or equal to 0. So negative x greater than or equal to negative 1, divide both sides by negative, x will be less than or equal to 1, meaning that the domain is from negative infinity all the way to 1. 1 is included. Okay, that is the answer for that question. But in a case where we have got a cube, let's say we have the cube root. Now I'm just making this question in a case where you come across such questions. Now what it means there is that if I have this, let's just put x, I can have any number here. The cube root of any negative number is still undefined. For example, the cube root of 8, or let me tell you, the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2, it gives me negative 8. That is what I have there. So if at all I have got a cube root, so this is the fourth root, we have a square root, cube root, and fourth root. So now, as long as there is 3 here, you should know that the domain, any number can fit. So the domain in that case, it will be from negative infinity to positive infinity in that case. Okay, so I'm just giving you a hint here. Now that we have talked about the radical function, let me jump, I go to part 5 so that I explain about rational function, then I'll come back and solve this one. Okay, so f of x is equal to 1 over, although the modulus is not going to affect anything, one thing we should know about rational function is that f of x can never be a number over 0 or 0 over 0. This is also undefined. Doesn't exist. Now to make this function defined, we have to make manipulation. We have to make something. Okay, so what I'm going to do is, I have to get what is on the denominator the way it is, x minus plus 1. It should not be equal to 0. The denominator should never be equal to 0. So for x, okay, x not equal to negative 1. What does it mean? Meaning that the domain is from negative, all the numbers can fit except negative 1. That's what we need to understand there. So all the numbers can fit except negative 1, meaning I can start from negative infinity all the way to negative 1. Negative 1 is not included, union, again starting from negative 1 to positive infinity. So all the numbers except negative 1. That's why where there's negative 1, I have put this, meaning this number is not included. Okay, so that's the domain. So for any rational function, you have to get the denominator, set it not equal to 0. So for x. Okay, but there are some cases where, let's say you have been given f of x being equal to 1 over x squared minus 4. Just get what is on the denominator. X squared minus 4 should never be equal to 0. X squared should never be equal to 4. You get the square root. X should never be equal to plus or minus the square root of 4. Then x should never be equal to plus or minus 2. Meaning that the domain will be from negative infinity to negative 2. Negative 2 should not be part of it. What I mean there, I've got x is equal to negative 2 and x is equal to positive 2. So union, again starting from negative 2 all the way to 2, but these are not included. Union, again starting from 2 all the way to positive infinity. So the 2 and negative 2, they are not part of it. Okay, I'm going to give you a question. Try to find the domain, and I'll be waiting for the answers in the comment section. So find the domain of f of x being equal to x minus 1, then x to the power, let me just say x plus 4. And also find the domain of 7 divided by x to the power 2 minus 16. So find the domain of this. So I'm waiting the answer in the comment section. Okay, Now, so for you not to confuse the way you are going to report these answers, let's get that this is 10 and this is 11. So when you are reporting, when you are typing the answer in the comment section, report this one as question 6 10 and question 6 11. Okay, so let's now see. So now another thing that we have to take note here is we are now going to, this is the combination of rational function and radical function. Quite okay, we know that on the denominator we can never have 0, but there is a square root. In the square root I can have 0. That is okay. Okay, so one thing I want you to understand is that the denominator should never be equal to 0, but again in the square root we are saying it should be greater than or equal to 0. So if there is a number and the square root is on the denominator, okay, the square root is on the denominator, what we normally do here is to satisfy this function, just get what is in the square root, equate equal greater than what? 0. Why am I equating greater than 0? So that the square root and the denominator should make the function defined. If I put greater than or equal to, meaning I'm including 0. Since the square root of x plus minus 3 is on the denominator, if I include 0, that is wrong. I can never have 0 on the denominator, so that can't fit. But if I put not equal to 0, again that is not true, because in the square root I can have 0. So then greater than only can fit, can suit both. Okay, so greater than 0, I can have a number greater than 0 on the denominator. That is cool. Again, I can have a number greater than what? 0 in the square root. That is cool. So greater than fits for both the rational and the radical. So that's why I'm going to use the greater than. So for this one, I'll say x is greater than what? 3. Then any number can fit here, so it will be from 3 not included, because it's greater than 3 all the way to positive infinity. That's the domain. So any number that I can put there, as long as that number is greater than 0, then I'm okay with it. So starting from 3, but 3 is not part of it. The moment I include the 3, if I do 3 minus 3 is 0, the square root of 0 quite okay is 0, meaning I've got 1 over 0, which is undefined. That's why I have put this open interval to show that 3 is not part of the solution. Okay, so that's how you find the domain. Now here I'm going to jump again, go to this. So in that case, we are only interested with what? The denominator, because on top there is just a linear. It's a linear function. So the denominator, it will be x greater than what? 0. It's the same as the one I'm from solving here. So starting from 0 all the way to positive infinity, that's my domain. Okay, now let us solve this one, this question. On top there is the square root. In this case is not on the denominator. So if that's the case, one thing we should remember, guys, that if that's the case, then for the top part only to be defined, the top part, forget about the denominator for now. I need to get x plus 1 greater than or equal to 0, because it is on the numerator. If it was on the denominator, I would have said not equal. Now in this case, I would have said greater than if the square root was on the denominator. But since it is on top, I'll say greater than or equal to 0. So for x is greater than or equal to negative 1. Let's end here. So we are saying that all the values, x should be greater than or equal to what? To negative 1. But for the denominator, it's not true. Again, denominator, you do it separate. X minus 2, we know that on the denominator, as long as there is no square root, should never be equal to 0. So for x not equal to 2. Now I've got two things. So you have to combine these two. But how can you combine them? Look at what is happening. The numbers of x should start from negative 1 going to positive infinity. But as you are going to positive infinity, excluding positive 2 only, meaning that it tells me that I can start from I'll start from negative 1, which is included, all the way to 2, but 2 should not part of it. Union, again, 2 should not part of it to positive infinity, like that. So this tells me that negative 1 is included all the way to 2, but 2 should never be included because x should never be equal to 2. Union, starting from 2 all the way to positive infinity. So the numerator here has changed everything. If I didn't have the numerator as the square root, the answer would have been from negative infinity to 2, 2 not included, then 2 to positive infinity. But now, because of the square root, if I do that, then on top there is going to be undefined. So I follow that, I follow the second one, I combine. Okay? Now from here we can go to the next question. The next question that I'm going to solve is this one. So this one now, down there, again is a combination. If I had only the square root here, I would have done the way this one, the way we solved that one. But this one is different because there is a number which is not in the square root. In that case, I have to get everything at first equate not equal to 0. So for x. So shift that one to the other side, it will be like this. To solve for x, square both sides. If I square both sides, it will be 1 is equal to x plus 3. Shift 3 to the other side, 1 minus 3 is equal to x, meaning that x is equal to negative 2. X is not equal to, x is not equal to negative 2. What does it mean? On top there, excluding the square root, x should never be equal to negative 2. But again, I've got the square root. I need to consider that. Again, I'm going to solve the square root on its own. So I'll get that should be greater than or equal to 0. So for x greater than or equal to negative 3. So now what is telling us is that any number from negative 3 going to positive infinity, but we have to exclude negative 2. That's what it means. Okay? So then I'll say that the domain starting from negative 3, so negative 3 is included because it is greater than or equal to. Starting from negative 3 all the way to negative 2. But negative 2 should not be part of it. Union, again negative 2 not part of it, all the way to positive infinity. This is my domain. Okay? Let's do the last one. So the last one here is very simple, but again it is separate. So what are we going to do? This one, okay, there are two ways in which we can solve this. It's either you can say the denominator there, the denominator is x and x plus 2. On top here, x and x will cancel, then you have x plus 2 minus, that one is going to be 3x, of which we are going to have now negative 2x plus 2 divided by x, open bracket, x plus 2, like that. So you know that this is a rational function. So this function that I have is basically the same as this function. But remember, the denominator should never be equal to 0. So I'll get this not equal to 0. So for x, in this case, x is not equal to 0, comma, x plus 2 should never be equal to 0, then x should never be equal to negative 2. So I've got two things. All the values can fit except negative 2 and 0, meaning that the domain starting from negative infinity all the way to 0, 0 should not be part of, no, 0 is greater than 2, negative 2, all the way to negative 2, negative 2 not included, union from negative 2 all the way to 0, but this should not be included, again union from 0 all the way to positive infinity. So these are not included because they are not part of the solution, guys. Okay, so that's basically the domain. So now I have used this method, but again, there's a simple way, like you can just get direct. Solve this one alone and solve that one alone. It's the same thing. So you can say you solve this one alone, it will be x not equal to 0, comma, you solve again this one alone, x plus 2 not equal to 0, x not equal to negative 2. And you end up having the same as the ones I solved here. Okay.